Howdy doody, guys. We're back. We're back with another show. Roundtable 28, Speed of the Sun with Crowxe. Now then, I have the presentation from him ready to play. One thing we do need to do, though, is get a full contact with him. His Skype is playing up at the minute, so I may have to do it through Facebook. I think that's how we did it last time. If that's the case, all good, all good. Now, in case you're wondering, yes, this is a dressing gown. It is still bitterly cold here because the boiler still isn't repaired yet, and it might be sometime this week, but we don't know exactly when it's going to get repaired. So in the meantime, we've just got to freeze, and so that's why, as you can see, dressing gown. Oh, here we go. 1 second, guys, 1 second. Hello. Oh, we have a connection. There we go. Right, hang on. Let me just put you through so that the audience can hear that you are actually there. Do you want to say hello to the audience?
Yes, I'd like to.
There you go. You're on now. Say what you got to say.
Yes, hello everyone. I'm glad to be again here on Randy's show. I've been a while away from the Flat Earth videos. I rarely watch any flat or globe video, maybe for the last 2 months. But Brian always, he's like my mate who always encouraged me to get back and do new things. So I'm happy to be here. That's it.
Yeah, and it's glad to have you back as well. To be fair, this topic between you and Brian, this sun speeds and etc. This is something, the analemma and stuff. This is something that not a lot of people look into as such. So this is why it's good to have a globe Earth perspective and a flat Earth perspective, because we're digging down into the nuts and bolts here. We're trying to get some answers going. So having this bit of back and forth between you two, I think, is pretty good.
Yeah. Yes, I think so.
Okay, right. Well, if you want to pop yourself on mute for just a minute, stay on the line, don't hang up, because now we've got a connection. I want you to stay on if that's all right. What I'll do, I'll put your video on now. I believe it's about 30 minutes or so. So I mean, if you just want to hang on, I'll get back in touch with you in 30 minutes, and yeah, we'll be ready to go. Is that okay?
Yep. Okay.
Yep. No worries. Right. Okay. So let me get your video ready to play. So it's a response to Brian's logic presentation. I'll just put it on pause, and here we go. Can you pop yourself on mute? That'd be great.
My response to Brian's logic presentation, Speed of the Sun. And this is a background for those who didn't see the presentation. The main subject of that presentation was studying the sun speed through comparing sunrise time in various cities on same latitude and repeating the process on different latitudes and seasons. It concluded inconsistency for the results on the globe. The presentation didn't prove consistency with the flat Earth either. The presentation subject is a good research area if it was done properly. The presentation touched on other related and unrelated topics. So that being said, now I move to my presentation. And my presentation goes in 3 sections. First section is my takes on the presentation, Speed of the Sun, the actual points regarding the speed of the sun. B, my takes on other matters in that presentation, and C, multiple tests that prove the parameters of the heliocentric model over and over. That's the axial tilt, the spin rate, etc. So the first section, my takes on the speed of the sun. Methods and concepts being used to measure the sun speed are inaccurate and lead to incoherent results that immediately debunks the flat Earth, yet the show goes on. I'll give more details on that. Second, the presentation ended up claiming that the sun speed doesn't make sense on the globe And although it included a fair amount of research and data gathering, it didn't include any example of predicting sun speed between two cities on the flat Earth to make the point. Third, the presentation was carried out with doubts and uncertainty regarding the effect of height on sunrise time. There is no rebuttal in this point, just to give information on that. So the first thing, methods and concepts. Number one, calculating the terminator line, and I will call it the terminator line because it works for both models. Calculating the terminator line speed on a tilted spinning sphere can't be the same as flat disk with the sun circling above it. The concept for the globe needs extensive research. And if there was such thing as flat Earth, we can easily calculate the speed of the sun or the terminator line for any location as latitude circumference divide 24 hours. And when I say latitude circumference, that's obvious that I'm talking about the flat Earth. Seasons even wouldn't matter. Number two, distances on the globe are measured through great circles, and distances on the flat Earth are measured as direct straight line. Both models ignore the curved distance along the latitude line. That's the path of the sun for both models, or at least for the flat Earth model. As you can see here, the black line is the line of latitude that we can choose to put our cities or to select our cities from, and the distance being measured is not on that black line, and the error would be significant, very significant in the flat Earth. Number three, the distance between reference cities was taken from a sphere. The fact that he used a computer software or website doesn't eliminate the inevitable, which is those distances would have been the same if he had used a physical sphere with the city's coordinates or a globe model of a good quality. I mean, some people can even calculate the distance if they learned the coordinates. So, not taking distances for the flat Earth from the flat Earth map renders the data and results inapplicable for the flat Earth. Number four, choosing cities that are not separated by exactly the same distances for different latitudes renders the data unusable. Number five, sun speed variations on same latitude, especially for the flat Earth, should have rang a bell of inconsistency and should have stopped there instead of assuming that averaging more cities will make things alright. No, it just added more water to the mud. Number six, Salta, Asuncion, and Curitiba are in three different countries with different start and end time of daytime saving. Salta has none. Asuncion and Curitiba are not using same time as Brian thought. They don't use the same time minus UTC until the 6th of October. Hence why Asuncion appeared to be ahead in time of Curitiba, which is to the east. Now, this point may seem a little bit vague, so I'll show this. This is the city in the far east of Latin America, and you can see in the 1st of October, the sunrise time is almost 6 a.m. So a city to the west of Curitiba should have a later sunrise to be behind it. But when you look at the 1st of October, you find it 5:30, and that's because they were not using the same time zone or daytime saving shift for that period. Starting from the 6th of October, as you can see here, it's 6:25, and if you go back on the 6th of October, 5:51. So now that makes sense, and there's no problem with the globe Earth in that regard. Now, I've been giving problems without solutions, so here's some solutions to do the sun speed tests. Number 7, the most acceptable method to calculate the terminator line speed is with the following conditions. 1, only when the sun is perpendicular on the reference cities. 2, only when the distance are equal between the cities on different latitudes. That will still not be accurate speed, but should give consistent results for the correct model. And so I make an example of 2 locations on the Tropic of Cancer during summer solstice and 2 locations on the Tropic of Capricorn during winter solstice with equal separation for both sets. And now let me show that. As you see here, this is for the summer, this is for the winter, this is for 2 cities in the north, 2 cities for the south. The difference between the time, the sunrise time is 20 minutes for both sides of the earth. And just to you can check these coordinates and you can go to suncalc.org and make sure yourself. So this is here an advice whenever you want to research the sunrise and sunset and anything about the sun, use suncalc.org. Excuse me, because you can just put any coordinates you want, and this enabled me to choose the distance or the separation between the northern cities to be 5 longitudes, and also the same for the southern city. And these are just random numbers. The only thing I cared for is to have just 5 degrees, because if it's more than 15, you might get into a different time zone. So the distance was the same and the speed was the same. And I think that concludes the sun speed presentation, if Brian made it this way. Now, next slide. Ground height effect on sunrise time. Number 1, timeanddate.com, suncalc.org, and other applications or sites, they don't account for elevation in their sunrise and sunset data. The output is purely based on astronomy and ignores ground features. And in order to confirm that for you, I'll compare length of day on several latitudes using suncalc.org and comparing them to my own sun calculator, which I made only based on my astronomy research and surely without any height data. So this is very simple. I just put the date, I put the latitude, and I get the length of day. So let's go to suncalc.org and let's go to near the Himalaya. It's not exactly the Himalaya, but it's an area with an altitude above sea level, like 4 kilometers, and it's 31 and 91 east. 31 north, 91 east. So here's on the 14th of October, the day length is 11 hours, 29 minutes, and 23 seconds. Let's put these data in my application. 14th of October and 31 latitude. October 14th. Latitude 31, 11 hours, 29 minutes, 30 seconds. Is that like the other one? Oh, what do you see? 11, 29, 23, 29, 30. So I'm like 8 seconds off. Now let's go to the ocean. We go to 150. So 11, 29, 40 seconds. Well, that's very close. It's not because of altitude. Now, for Brian, he asked me once, how can he have like 16 days of of daylight in his latitude in Ireland. So I'll put that to be exactly 52. In the summer, so let's go June 20. So it's 16 hours 45 and 2 seconds. Let's put that data here for me. June 20, latitude 52, 1644 and 50 seconds. I'm off by 15 seconds. So I don't think I need to explain anymore how the day length work in the globe, because I can calculate it. I can make a presentation about step by step how to make the equations to calculate the day length if anyone challenged me to. Now let's continue with the presentation. We go to the next section. My takes on other matters in the presentation. One, the heliocentric model on the globe deals with insanely large distances, unlike the flat Earth. Hence, most of the globe astronomy tests deals with the angles without any significant impact from distances. While the flat Earth is limited to smaller distances, consequently, all results would be impacted by parallax and perspective, but we don't see that in reality. Second, science is not about history. History is stories that can be altered, deformed, and decay with the storyteller bias. It doesn't matter who discovered what, as long as the what can be tested and confirmed. That being said, all things told about Kepler, and I mean it, all things told about Kepler was either wrong, incomplete, or irrelevant to his achievements, except maybe for dates. Third, gravity is about masses wish to clump together. All attempts to debunk gravity through apparent conflicting definitions is a lost case. And I'll give more explanation on that. So the first thing, globe angles and flat Earth perspective. In the globe model, the change of Earth speed is 3%, 29 to 30 kilometers per second. This 3% reflects on the approximately 1 degree daily change in the relative position between the Earth and the Sun, deforming the perfect figure of 8 of the analemma that would have been resulted if the Earth orbit was a perfect circle. In the flat Earth model, the Sun changes speed by 70%, and this 70% reflects directly on the angular speed of the Sun on both tropics. The above being said, we can clearly see that the globe and flat Earth has nothing to do with each other's, and none of them was derived from the other. Simply, the globe is reality, and the flat Earth Sun's motion is tailored to roughly resemble reality, not exactly reality. So let me show this. I'm going to talk about the sun speed in both models. Yeah. So this is for the flat Earth, and this is for the globe. You can just punch in here any latitude, and you'd get the speed. So on latitude 23.5 degrees from the North Pole is 66.5, and that's how we can measure the circumference. For the flat Earth, that would be 46,000 kilometers. For the globe, it's calculated differently. It's the latitude circumference, which is 36,000. As you see, that is less than the 40,000 of the equator circumference. So sun speed on ground would be on the flat Earth would be 1,937, and on the globe would be 1,530. Now, the maximum sun speed for the globe is not this or any number derived from this. The maximum sun speed in relation to the Earth is 30 kilometers. That's the Earth speed. And 29 kilometers as minimum. That's also the Earth speed in its orbit. So it's not the terminator line speed. In the flat Earth, terminator line speed is the sun speed. So let's go to the Tropic of Capricorn, minus 23.5. And as you see here, it's 3,300, which is this one. So you see now we have the ratio of 171% on its maximum speed. Well, here is 103. Now we go back. So we have two solar analemmas here. This one is for the globe and this one for the flat Earth. As you see here, if the sun was physically moving, not the Earth tilt causing the analemma, it would have moved up and down 130 million kilometers at a distance from us of 155 million kilometers. There's no distance on Earth, and this is not a metaphor, this is actual statement. There is no distance on Earth that could change your perspective or your angle to the sun, no matter where you go. While on the flat Earth, you see here the width or the length of the solar analemma from tropic to tropic is around 5,200 kilometers, with an altitude of 5,000 to 7,000. Nobody really knows, just all assumptions and hypotheses. So this guy here is standing on the Tropic of Capricorn, and this is the Tropic of Cancer, and maybe this guy is in Europe or the UK. And if both guys are looking at the solar analemma in the sky, you can see here the field of view for this guy is not the same field of view here. And this guy is standing closer to the bigger loop and further away from the smaller loop. That would make this one even look bigger than this one, as we see it right now. That's perspective. And the opposite will happen to this guy. He will see this one a little bit bigger than it should, and this one is a little bit smaller than it should. And I made a small image with the analemma dimensions given to me by Brian, the bigger loop being lower in altitude than the smaller loop. So this is what the guy on the Capricorn is going to see. And for the guy in Europe or Cancer, you would see it like this. The image was dismissed without explanation and without even showing an alternative. Now, still talking about the sun angles or the sun speed, but in this sheet or this slide, I'm showing the angular speed of the sun, the effect on the globe, and the effect on the flat Earth. And as you can see here, for the globe, there's only one variable that control the sun angular speed. And when I say the sun angular speed, it's like when it's enter your screen and leaves your screen, you can measure that angle. The angle on both models is 15 degrees per hour. But if you are observing the sun, you're not going to see exactly this. Imagine an airplane flying overhead. That's like the flat Earth sun. When it's get closer at noontime, it will be faster. So that's what I mean by angular velocity or angular speed of the sun. And I was lucky that I stumbled with an experiment, real-life observation for the angular speed of the sun on the 26th of June, 2018. And what's beautiful about this observation, two things in fact. The first, that it was taken from 2 locations on the same day. The second, that it is made by a flat earther or a couple of flat earthers, thanks to Dave Marsh. So the observed angular speed was 13.74. My prediction, according to the globe geometry, was 13.77. And guess what? The flat Earth, 2 different results, and both of them are far more than what we observe. That's all because of the closer distance and the perspective. Now the last thing, or no, the second thing, history and Kepler. And to remind myself, I put the 3 statements that I put: wrong, irrelevant, and incomplete. So what's wrong? 2 things. Kepler did not observe the stars nor the sun in his research. Second thing, Kepler did not make observations for the solar analemma. That's what was mentioned, and that is wrong. The second thing, the irrelevant section, Kepler did not need a telescope. So I don't know what's the fuss about the telescopes being made after Kepler or during or after he made his laws. Because his observations and all the observations that he used was focused on the planets, and we can see the planets with our naked eye. Later on, he improved a telescope that enabled him to observe the moons of planets, and this helped him to make his laws more accurate. Kepler concluded at the end, that's the incomplete section here. Kepler included at the end that planets orbit the sun in elliptical path without explanation. Later on, Newton found that the reason is gravity and how it relates to the square of the distance or the square of the radius. I think you cannot notice the beauty of this point. The beauty of it is that someone finds something and he cannot make sense of it. He cannot explain it, but he documents it. So this is the reality that he found out without any explanation. He could have manipulated some reality that sounds logic or makes sense, but he didn't. He just showed the reality that he observed without explanation. But then Newton came and found out the reason. So the last thing, the incomplete, Kepler concluded Earth orbit through observations of Mars. That's how he found the relation between the Earth and the Sun, never by looking into the Sun or the solar analemma, nor knowing at that time that the Earth's speed is changing or speeds up or slow down, except with the aid of Mars observations. So it's been mentioned like dozens of times in the presentation that Kepler looked at the analemma, and that analemma derived from the flat Earth. But no, I've looked hard, and I couldn't find anything that relates Kepler to the solar analemma. So that's about Kepler. Second thing, or the last thing in the presentation, Newton versus Einstein. Well, first, Newton said that there is a force, direct force between masses that cause them to attract. Mainstream science said, no, that's wrong. There is no force between masses that cause them to attract. Rather, it's the curvature of time-space that makes objects slide on that curvature towards each other. And they accelerate in a certain rate according to their mass and their distance. And now imagine if that smaller mass is a planet, it wants to go towards the Earth because of that space-time bending. Now we still don't mention any force here, but why doesn't that mass go towards the sun? Because it's moving in a curve, because it has speed. And when you have something with a speed going in a curve, you get what? You get centrifugal force. So that centrifugal force is working outward, want to push the planet outward. But why does the planet still orbit the sun against that force? So it's a force opposing a force. That's why the planet stays always in balance and always in orbit around the star. Um, this is just saying the same. Gravity as mass attraction is not a force. Okay, I agree. Because there is no attraction force between masses. That's it. There's no direct force between masses. Masses move towards one another due to their combined space-time bending. It requires an opposite action or force to stop them. So that's it about Newton and Einstein. Nothing more. Now the final part of my presentation, multiple tests that prove the parameters of the heliocentric model over and over. So the Earth being a sphere, 9 tests. Spin rate around 15 degrees per hour, 8 tests. Axial tilt 23.44, 10 tests. Orbit eccentricity 0.0167, and this is from Kepler. Thank you, Kepler. So let's go to these tests. So as you see here, marked in green, the heliocentric parameters, and I add the moon, but you can forget about the moon experiments, although they have to put in some of the other parameters. So the first one, sun declination angle, and this comes from Earth being a sphere. It has axial tilt and the orbit eccentricity. The sun angular speed, and I showed you how I can calculate it based on the rate and axial tilt and orbit eccentricity, because it comes from the declination angle of the sun. Length of day, the sun azimuth, the sun elevation, the solar analemma. Improvised method to confirm R. You can say that this is a presupposition or whatever, but this is a method that no one ever used before. And when I tried it, guess what? It gave me also the well-known radius 6,300 and something. The moon phase value, I can calculate it. Moon phase orientation according to your latitude and the time of year. Number 10, moon phase apparent rotation, or called as or known as the field rotation. And 11, eclipse path, the solar eclipse path prediction. So I'll just mention 2 examples here, the number 6, solar analemma, and number 10, the moon phase orientation. So the solar analemma, you see here some marked in green, blue, red. Red is the start, position is the end, and green is what's going to be used. So use Kepler laws to define the Earth position in on its elliptical orbit. And from that position, use Earth position along with the axial tilt of the spherical Earth to calculate the declination angle of the sun at any given day. Now, using that declination along with the Earth spin rate to get the elevation and the azimuth every 24 hours, 365 times a year. Plot the X and Y. That's it. Simple. Now, here it is. I do these 4 steps in around 40 equations, and I repeat them, or I copy them 365 times. And at the end, this is what I get. Now, if you can see here, this is the eccentricity and this is the tilt. And if I change the eccentricity to 0.01, only 0.01, this is not the analemma that we see. It has to be 0.0167. And if I change the axial tilt, let's say 15, this is how it would look. So it has to be like this. It has to be axial tilde of 23.44 and eccentricity of 0.0167. Now, I did explain the analemma, or how do the basic math for plotting the analemma. Now, I don't think I need to explain anything anymore. I just give the results here. And until the flat earth give results similar like that, even if it was some ugly, deformed results a little bit, I don't mind. But I need results that I can calculate it to confirm the numbers. So this is about the solar analemma. What else? Yeah, I made a video just because I didn't want to make this presentation very long, so I'll play the video here. I went to Stellarium, and you can use anything similar to Stellarium. If you don't like it, you can use mooncalc.org, or you can make a real life observation and just give me the date, and I'll compare it with my application that shows the moon orientation in the sky. So this is here the terminator line, or the top of the moon and the bottom of the moon. This is the top and the bottom. I call them like this just for short. And I will start adding 1 hour here and 1 hour in my application, and you'll see how they go exactly like each other. Turning left, 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 and left here, left and left here, left and left here again. Now started to opposite direction and flipped, and then right, right, left, left, left. So I think you can see it. I don't have to keep saying left and right until this is now here, moon set, and you can see it here, the moon setting. So yeah, I can do all these things using these parameters of the heliocentric model, 11 or 10 experiments with results, all of them. And I documented all of these tests. They're all in videos in my channel. So the speed of the sun is something not to be taken lightly. It needs better research, and I urge people to try to do it more with, I don't know what to say, just consult each other and get whatever results you're going to get and compare it with reality and try to see what's the truth. Thank you.
Okie dokie. Let's see if you're there. Crow, are you there? You might be muted, so you might need to unmute yourself. There we go. That's better.
Hello?
How's it going?
Yeah, I'm here. Sorry.
Yeah, no worries. I suspected you might have forgot you was on mute.
I was using headphones with the computer, so I didn't hear you on the phone.
Right, no worries. Right, okay. So before we get started, I do have some things ready to ask you. Firstly, though, we have a compliment from Sean Hawkins, who says, "Ranty Flat Earth, this is a very good presentation."
Well, thank you. I'm flattered.
Okay, so that's the best of it up to now, but now we're going to get down into some of the flat earthers asking you some questions. So we have from Mason B. Ranty Flat Earth, my question is that why is he using a globe model software? Already begging the question.
Well, yeah, I expected this to come, so I said, do your observation for the moon on any date, and don't just tell me the date, and don't show me the observation, and I will predict how the moon is rotating upon your real life observation. If you don't like those softwares, although those softwares are used by flat earthers for experiments, so they are authentic.
Okay, so Rakia Life is He's demanding this question answered. I don't know why. It's hardly relevant, but I'll ask it anyway. He wants to know the size of your shoe.
I think 7.
Size 7. Right, there we go. Rack here, it's a size 7. There we go. Right, LBB Store says, if I move my telescope 5 centimeters, Polaris falls off the scope. Yet as Earth travels millions and millions of miles in an analemma pattern, Polaris remains on my scope. How is that possible?
Distance. Like if an ant is moving all day, the angle from that ant to a far mountain like 100 kilometers away will not change. So if you are criticizing the globe model or the heliocentric model, then include all the numbers, the distance to the stars. Now you can say that the distance to the stars is a lie, and that's it, but don't go into parallax, because parallax depends on distance. That's it.
Okay, so from Mason B, essentially, what is the sun?
The sun, I'll tell you what I can conclude about the sun on my own. It's an object that radiates heat and light. That's it.
Is that all your answer? Yeah.
Because I know that some people say the sun is a hologram or stuff like that. So for me, for myself, if I don't take any word from NASA or any mainstream science, all I'm sure of, that the sun is an object very far away, more at least not less than 2 million kilometers. So it's very far.
Okay, so again from LBB Store. Question, you keep stating what we observe. Is it possible for us to observe with our eyes without optics and perspective at play? If not, where do you incorporate both in your observation data?
Can you ask that again?
Okay, so you keep stating that we observe. Is it possible for us to observe with our eyes without optics and without perspective? If not, where do you incorporate both in your observation data?
Most of the observation can be done by eyes. Like I've seen people plotting the solar analemma on a wall. They have something that makes a shadow, and then they point, they mark the shadow on that wall every 24 hours, and the marks at the end give the shape of the solar analemma. So we don't have to use optics, we can just use our eyes.
Okay, so next question from Mason B. Ask the fundamentalist for evidence to the distance to the sun. So what is your evidence for the distance to the sun?
Okay, I've just mentioned it. It cannot be less than 2 million kilometers. I don't know what's the distance to the sun on my own. I cannot calculate it. They say there's a way to do it with Venus or Mars or something like that. I never looked into it. I don't have the tools or equipment to do that. But I say it's not less than 2 million because of I did some calculations, and it cannot be any closer.
Okay, so from Erwin Jansen, what do you mean by heliocentric details being stated on the paper?
Okay, it means that like the parameters of the heliocentric model, the Earth orbit the Sun, the axial tilt, the spin rate, those are what I mean.
Okay, so from Flat Enough, Kepler, ridiculous. One assumes mass is a thing. Earth, Sun, etc. are spheres. The distance between them are known. Their masses are known. And that mass attracts mass. Now he's going to say that all of them are assumptions. What would you say to that?
I don't know. He sounds like he's supporting the globe, and then he's saying your assumption. I don't really get the question.
No, I think what he's doing there is he's quoting all the things that you've done in your presentation. Kepler, one assumes mass. Earth and Sun are spheres. The distance between them are known. Their masses are known, and that mass attracts mass. He's saying that they're assumptions. Would you agree that they are just assumptions?
Uh, well, eventually you can assume that there's a cat in the books, and when you open the books, you find a cat. So you start by assumption, and then you conclude that this assumption is real.
Okay, so from Domesticated Primate says, how can a conceptualized construct be bent? I'm assuming we're talking about gravity here. And if it can be bent, how does it give the weakest force non-force presumed force?
That sounds too complicated. Did I sound that smart to be asking that question?
Well, listen, if you're here doing a presentation on this kind of thing, you're going to get some smart people asking you some very tricky questions. So, so I'm assuming that they're going to want an answer with that.
Yes. Okay. So I think he's criticizing this concept of space-time bending. Actually, I don't like this explanation. But this is the mainstream science that the flat Earth is currently using to say that gravity is not a force. And you don't have to use that. Gravity is not a force. Gravity is acceleration. Because if gravity is a force, how much is it? Ask this question to any globe earthers who insist that gravity is a force. Tell me how much is that force? He will tell you 9.8 meters per second square. That's an acceleration, not a force. So regarding the space-time bending, we see this sheet where they put something heavy in the middle and the sheet is bending. But for me, I try to understand it that space-time bending is like an area of low pressure and area of high pressure. So the way I understand it, or make myself understand it, is maybe like the sun is making sort of a vacuum around it, and that vacuum sucks the Earth, which is going in an orbit. So that's how I like to look to it instead of the sheet bending.
Okay, so the Adam Meakin asks, why is the moon not in the same proportions to the sun when viewed from altitude balloons? Does this affect the presupposition in presentation with regards to inference of measurements?
I think he's saying that the moon and the sun do not appear to be the same size when observed from balloons.
That's correct, yeah. Yeah.
Well, unless this is shown with a solar filter, but again, how can you see the moon with a solar filter? I don't know. So there should be a solar filter for the sun, and then maybe the camera removes the solar filter and pans to the moon and compare the frames.
From Rare Helium, who's just popped a question now, says, ask yourself, if the sun exists in a place that violates the second law of thermodynamics.
I'm not sure what he means, or I'm not sure what's the second law of thermodynamics. I know that the sun, or I was told that the sun is a fiery ball of nuclear reactions. It doesn't require oxygen, something like that. So, but I told you, all what I'm sure of about the sun, it's an object very far away.
Then I'll not ask you this question then, because I was going to ask you how long does he think entropy will last, but if you don't know the second law of thermodynamics, I won't ask you that one.
Yes, exactly.
Okay, so from Ninja Man, with a sun 93 million miles away, a fireball, why don't most of us have 12-hour days and nights and a similar climate?
Oh, days and nights. Well,
12 hours days and 12-hour nights.
Yes. Well, I can just tell me your latitude and the date, and I tell you how long your day is supposed to be. So I know how it works, and I can calculate it. I have a spreadsheet for it. So I know the concept. I have the numbers, the basic numbers. I use the concepts with the number. The concept is the Earth is a ball that spins. The numbers is one spin every 24 hours. When I use those, I get the results. So yeah, that's it.
Okay, so where do you get the data from on a spin?
Where do I get the spin?
Yeah, you just said that you get data from the known spin, etc.
Yes, the speed that we are told, the spin rate that we are told, it's not exactly 15, by the way, not exactly 15 degrees. But when I punch these numbers, let's call it the assumption, the 15 degrees, call it an assumption. And when I put that assumption with the concept, which is the sphere, it works and gives me a prediction of reality.
Okay, so it's an assumption coupled with a concept. Yeah.
Yes, as I said, we can start all with assumptions, and then we confirm by comparing that with reality.
Okay, let's see what else we've got. So I've just asked that question. Okay, so from Erwin Janssens, who says he claimed that the sun has to speed up on a flat Earth, but does his model do the same? Things, same signs. The Earth has an elliptic orbit. Okay, right. So essentially, he's saying the sun has speeds on a flat Earth, but does your model do the same when the Earth has an elliptical orbit? I think that's what he said. Maybe he needs to come back and retype that so that we all understand that particular one.
Yeah, okay.
Okay, right. So from the Adam Meakin, is the reason the sun has to be over 200 kilometers because of the Earth has to be a ball, so the angles push it out to that distance?
What, 200 kilometers?
Sorry,
what was
is the reason the sun has to be over 200 million kilometers because of the Earth has to be a ball, so the angles push it out to that distance? 93 million miles, I think that is.
I don't know how to answer that. It's just I'm using observations and some numbers that are given to us, and that's what I use in my confirmation. If you want to say that the heliocentric model is tailored in order to match reality, well, what those people 400 years ago used, what's the tools that they were using? I checked the inventory of Kepler. It's funny things, you would laugh. A bunch of metals and rulers. This is what he used 400 years ago, let's say, to formulate a lie. Now, currently, we're on the internet. We have communications with each other. We have amazing gear. We have cameras, telescopes. I mean, in the position of flat earthers. We even have fiber optic gyro. We have all of that, and we have the communication, and we can coordinate tests. And until now, there's nothing that can formulate the reality as flat earthers believe.
Okay, does it? I mean, this is from a personal perspective, but why would you think? If you're saying that 400 years ago people were able to do all this with just rulers and pencils, why do you think there's such an uprising here with the idea that the Earth may be flat? And why do you think that the mainstream haven't been able to put this to bed?
No, those I cannot answer the second question. But maybe the first question, why people thinks the Earth is flat, is what do you call it? Inconsistency, maybe. Things that doesn't make sense. Like for example, when I saw some of Brian Mullen, right, or David Mullen, that engineer who used to make videos about the flat Earth, and he once said that the temperature in the region where the International Space Station is 2,000 degrees. So how doesn't it melt? Yeah, that question drove me crazy, but I don't understand much about what that's thermodynamics. So it maybe it's based on lack of understanding of some things. Maybe, I don't know.
Okay, so from domesticated primate, I'm going to sort of like elaborate on this particular question. But essentially, if Earth is a globe, how was r, the radius, ascertained?
How it was calculated?
Yes, how was it calculated?
Okay, there's some Greek man who measured the distance from Aswan, that's my Syene, and Alexandria, in my country, Egypt. And also there's after Islam, when Islam started, you know that Muslims, when they pray their 5 prayers, they should be aiming to Mecca. And when the Islamic Empire expanded, people needed to know directions, and they couldn't know directions without coordinates. So there was that Khalifa or something who ordered a scientist to measure the circumference of the Earth in order to give directions or the angles for 81 in the Islamic Empire to be pointing to Mecca. So that man went up on a mountain and measured the dip angle for the sea, and he concluded the Earth's radius, and it came something close to what Eratosthenes, or what's that Greek man, did.
So how long? Sorry, can I just ask how long ago was that?
I'm not sure. Maybe I'm not really sure, but the man is called Al-Biruni.
Okay, is there written documentation of this?
Yes.
Okay.
Al-Biruni during Al-Khalifa Al-Ma'mun.
Okay, that's cool. Carry on.
So yeah, this is the way. This is 2 ways, different ways. I myself came up with a whole different way than the one that I mentioned or pointed to in my presentation. I checked the longest routes, one of the longest routes in aviation. It was from Doha, Qatar to Auckland, I think. Now I know that distance. And from those 2 locations, at a certain point, the sun will be, or let me say it in a different way. If you are in Doha and you are looking towards Qatar, looking towards Auckland, and from Auckland looking towards Qatar, those 2 angles, when the sun is in the middle, you can measure the elevation angle, and then you do. I can't really say it in words, but when I did the calculation based on this method, no one told me this method. It's just I'm checking what's the globe saying, and I'm trying to find any trick to see if they're wrong. But it came true. And maybe I can post you the link to the video. I already have it.
Okay. Yeah, you could do. If you could do it after the show, that'd be great. But we have a statement from Dreads, better known as Musicians for Truth, and he says Al-Biruni was a flat earther. What would you say to that?
Yeah, good luck.
Okay, right. So moving on. From domesticated primate, how come we don't feel any acceleration or deceleration during the Earth's orbit?
Okay, so it depends on what's the acceleration, how much is that acceleration, and then I can answer why aren't we feeling it. So if he calculated this acceleration and came to be like half a meter per second, yeah, we can feel that. Half a meter per second, we can feel it. But if it's like 3 millimeters per second square, we don't feel it. So there should be a number that he provides before he asks that question.
Okay. Do you not know that particular answer?
No, I don't know the particular number,
Right.
but it's very small. You don't feel it.
Okay, so from Pete Shea, ask him, have you considered a flat plane with the sun as a circle in reflection against a contoured barrier? If not, will you admit that the sun appears close to our senses?
No, I cannot judge the sun distance by my eyes. I don't trust my senses. And regarding considering different concepts for the flat Earth, I did. I did many times, but I couldn't reach anything.
Okay, so from Rakia Life, he asks, are you a teacher or a professor or anything like that?
No, I'm a retired Army officer.
Retired Army officer. Okie dokie. So from the Adam Meakin, are observation angles adjusted to the presupposition that they are taken from a ball before they are used for calculations? Or is the direct crude data from the observation used?
Direct crude data, we check the data, we get them from the observation, and then we do the calculation, just like I did with my spreadsheet and going to suncalc.org. I consider suncalc.org as real observation because there is no time when someone measured the angles of the sun and then didn't match these sites that we use. They are used by everyone at both sites.
Okay, so the first part of that would be basically, do you presuppose a ball before you use your calculations? You would say that would be a no.
No, my calculations are based on a ball. So yeah, if you like to call it a presupposition, yes, okay.
Okay, so again, Oxbow Spirit agrees. He says you did the calculations with R, with radius. Yep.
No, I didn't. I showed 11 tests or 11 experiments. The only one that I excluded, I said that one of R, I will exclude it. All the other tests does not consider the Earth radius or the sun distance or the moon distance. They don't consider those distances. It's all angles in all my research.
Okay, so as you can see, I've asked all the questions up until this point, so I'm just going to wait and see if a few more questions come in. I'll give it a minute or so, and obviously if nothing else comes in, we'll wrap up, and if we get some more questions, it'll be, if you don't mind, I'll put them to you.
Yeah, okay.
So from Domesticated Primer, this is more of a statement type of question. So everything is pointless because a globe is already presumed.
I think this is kind of rhetorical question. I have no comment.
So from Brian's Logic, Ranty, SunCalc and time and date, etc., are all based on an Earth going around the Sun.
Yeah, I think so. Yeah, of course. I didn't see their codes. I didn't see their calculations, but they match reality and they match what I calculate when I use the sphere, the axial tilt, the spin rate. Maybe they are using the same equations that I do, but the equations that I used, I didn't get them from some astronomy book or something. It just I put the model in my mind. I tried to understand it, analyze it, and came up with the equation bit by bit. That's all I did. I didn't study any astronomy at all.
Okay, wow, right, okay, the questions are firing in thick and fast right now, so let me start with, from LBB Store. Okay, so this is from, he's made a quote here, so he's quoting George Ellis in the Scientific American, who says, I can construct you a spherically symmetrical universe with Earth at its center, and you cannot disprove it based on observations. What do you think of that statement from George Ellis in Scientific American?
Well, I'd like to see that fictional world that this scientist is going to do, and I challenge him that I can debunk it. So just words.
Okay.
Sorry.
Okay. Well, LBB Store, if you want to leave the link, I will moderate you for the rest of this. In fact, I might even moderate you permanently. If you want to leave a link to that particular quotation, I'm sure that Crow will be interested to have a look at that after the event. So that would be great. So from Flat Earth Data, what real-world observation have you done to test Earth curve? Do you think boats go over an edge at 3 miles if you were standing on the shore?
For Earth curvature, I didn't do any tests.
Right, okay, so none of your own, yeah?
Yeah, but I'd like to add something. There's no observation that can prove that the Earth is flat. I mean, if the Earth is flat, you cannot even prove it by an observation. And let me tell you this: if you are standing on a mountain with a known altitude, and you can see the base of a building very far away and below the mountain. Now, if you know the distances, you can calculate the dip angle. And we're talking about flat Earth, okay? So now when you measure that dip angle, it will not match the calculations, because the refraction, and you've shown a lot of refraction all the time. So even observation to prove that the Earth is flat, it cannot be done.
Okay, so we have a question from Paige, who says, why didn't the Ares failure experiment need to tilt the telescope?
Okay, the Ares thing. Before we talk about Ares, we should talk about Bradley, the one who discovered that we should tilt the telescope. And this tilt is not permanent. In one time of the year, you should, if you punch in the numbers or the coordinates for the star, you will not find it in the center. You should tilt your telescope by, I think, 10 arc seconds. This is because the Earth speed in its orbit, so it's something like when the rain is falling perpendicular, but you are moving with a car, so the rain has an angle towards you. This is what they call it, the light aberration. So what Airy thought of, if light aberration is a thing and it's real, and he knows the reason for it, he can calculate the difference between the light aberration in air and in water. And he put water in his telescope, but it failed, didn't work. So, but the origin of Airy, it is based on that the Earth speed is 30 kilometers. And again, I did calculations, and I showed the I predicted the curve that Bradley encountered. Bradley didn't know the light aberration. He was originally looking for stars parallax, he observed two stars, and he plotted the expected chart for those stars based on parallax, and he got a whole different results which he couldn't understand. Later, he realized that this is because the Earth's speed.
Okay, so from Dave Poole, it's more of a statement, but he says that Nathan Oakley and others did a sun tracking and found that sun calc was out by an hour in some places.
Okay, so this is exactly, or I think it could be the same case when Brian said that there's two cities, Curitiba and Ascension. There's some inconsistency. It's because daytime saving. Sometimes people just know that these cities, they both have the same daytime saving, but the daytime saving doesn't start at the same date. So maybe this caused or showed the inconsistency.
Okay, so you're saying it's more an error, a flat Earth error of time or understanding the time zones as opposed to anything else?
No, it's an honest error that could happen to anyone. Just we know that two cities are using the same daytime saving, so we expect them to have results in a certain way. But there's a trick here. The daytime saving does not start at the same time for some countries, or for every country. I don't think they are the same.
Okay, so again, from Brian's logic, what he said about sun calc always matching observations is not true. Again, I suppose that ties in with the last statement, essentially saying that sun calc might be incorrect, but your rebuttal to that would be it would just be a time zone issue. Yeah?
Yeah, I'm not sure if that's what he's referring to, but I made many observations for the sun, like a lot. I measured the angles, so the all was matched with all the sites that we see, and it's not only me. There's many people who did that.
Okay, so we have a question from, again, Ninja Man, who wants you to try and provide more up-to-date proof for Earth's radius rather than relying on stories from a Stone Age man.
Yeah, I've just made my own improvised methods, and I measured the Earth radius.
Okay, so will you be publishing those in a journal or something?
Yeah, I have a video already about it.
Okay, on a video, yeah? Right, okay. So from Flat Earth data, what causes the sky to converge, the sky and the ground? The ball Earth or our eyes?
Well, they should converge in both ways. Either it's flat or a sphere, because it's simply two mediums: a solid medium that we're standing on and nothingness. Call it air or call it vacuum. So there should be a distinguished line between them. That's it.
From Pete Shea, what would you say is the most convincing argument that you've come across for a flat and stationary Earth?
At some point, the most argument that really made me think was the gyroscope in the airplanes, and why doesn't keep showing that the plane is tilting down or dipping its nose down. Because when we go on a curve and the gyroscope remains its rigidity in space, then this should be showing as if the plane is pointing down every hour. So this really got me thinking, and when I made my research and look into it and understood the gyro, I realized that this gyro is called Earth gyro, which is governed by gravity or whatever that causes things to fall down. It's more like a plumb bob plumb bob, I think we call it that.
Plumb bob, yeah.
Yeah. So the gyroscope, there's a part of the gyroscope is like a plumb bob.
Okay, so from Brandon Toy, do you find it odd that there are always discrepancies and inconsistencies with the heliocentric model that need to be explained away?
Not always, very rare, and usually because it's about things that I don't understand at all, like relativity, for example. I can hardly understand relativity or thermodynamics. So, but regarding geometry and objects and angles, I cannot find any inconsistency.
Okay, so from Flat Earth Data, he says that we're talking about the convergence here between obviously the sky and the floor, but he says, so he said it was both, so obviously globe Earth and perspective, your eyes. What about a hallway? They converge into a point and there's no humidity.
Yes, that's true, they converge. Yeah, I understand now. A hallway should converge. But if he, yeah, okay. If he has another question, I'll not predict it. Yeah.
Okay. Mason B comes up with a pretty good question right now, who says, ask him for evidence of axial rotation. That's where, that's what this all comes down to. And essentially it does. This all comes down to axial rotation. So what is your evidence for that, please?
Axial rotation.
Spin, Earth spin.
Yeah, that the Earth is spinning.
Yes.
Okay, so I was told that the Earth is spin at a certain rate, and it has a certain tilt angle, and I put these concepts and these numbers to test, and when I test them, the results come matching reality.
Okay, is that all you have for that question?
Yes, I showed the lists of those 11 or 10 tests, and almost every one of them has the axial tilt. If I don't have the axial tilt, the spin rate. If I don't have the spin rate, then I cannot do anything.
Okay, so from Globebusters, you say the acceleration rates of the Earth are too low to be registered by the vestibular system. Why are accelerometers unable to measure changes at 10,000 times more sensitivity?
Okay, so if the gravimeter, is that what they call it?
The gravimeter. Yeah.
Gravimeter, yeah. So if the gravimeter sensitivity is supposed to pick it, then it picks it.
Is that it? Is that what you got for that question? Yeah.
Yeah.
Okay, right. Rakia Life says, how can we have gas pressure without a container?
How do you have gas pressure without a container? Well, I think that was shown in an experiment without a container or without a seal. Is that what he means?
No, he means a container.
Okay, so because okay, let's say this. Presume that the Earth does not have atmosphere at all. And then at some distance, let's say 1,000 kilometers, release some gas molecules. Where are they going to go? They will not just puff into space. Yeah, they will puff into space, but then they will go to Earth. And when they go to Earth, when you release more and release more, they pile on top of each other and end up causing pressure at the lower area. So that's how we have gas pressure next to. Did he say vacuum? Because
No,
because
he didn't mention vacuum, but you can interpret the question however you like.
Yeah, okay. So, by the way, the balloons, the helium balloons, that all of these helium balloons that we see, they are flying in vacuum. Technically, it's defined as low vacuum. So there's no such thing as like a defined line between our sea level pressure and vacuum. It just gradually reduces.
Okay, so I want to revisit the question from Globebusters, so I'm going to say it again. Because he wants a question, and it's to do with accelerometers, not gravimeters. So it's to do with accelerometers. He says that,
Okay.
yeah. So he says you say the acceleration rates of the Earth are too low to be registered by the vestibular system, right? That's your quote. But he asks, why are accelerometers unable to measure changes that are 10,000 times more sensitive?
I don't know really if I just being provided by numbers that I can confirm, but if it's within the sensitivity of the accelerometer, then we should feel it. I mean, we should get a reading from it. Ask him if he ever used one of these accelerometers, and I hope he's not referring to his phone because these are useless.
Okay, so if I think what he's saying here is that if the accelerometers that are 10,000 times more sensitive still cannot detect or register anything, then you quoted the vestibular system. Also, you said that he says the acceleration rates of the Earth are too low to be registered by the vestibular system, and even accelerometers are unable to measure them that are 10,000 times more sensitive. So at what point are we ever going to feel these changes?
No, I cannot answer at what point should we feel it, or at what point a certain device should detect it. It depends on our senses or the accuracy of the device versus the acceleration that we are inspecting.
But didn't you say you didn't trust your own senses with the sun?
Yes, with the sun, I cannot trust it at all because this is supposed to be very, very little. So we cannot feel it. And yeah, there's a lot of things like when you're at night, the gravity should be less because you are farther away from the sun. And at daytime, it should be more because, but you know, it's all in very, very small numbers. I once tried to calculate it and it was very minimal.
Okay, does it concern you that the acceleration rates of the Earth cannot be measured with any technology we have currently?
Where did that information come from?
Well, if obviously, if accelerometers can't find it.
What's the vestibulus?
Vestibular system.
That's in our body? What's the vestibular system?
Okay, well, this was your quote.
Yeah. Okay. So I just don't know the word. I suspected that it's a part of our organs that detects acceleration. If a device is sensitive enough to detect these accelerations, but it doesn't detect it, then he should provide that before he asks the question.
From the Adam Meakin, if we give that the sun movement is due to the ball Earth spinning or rotation, is the observation of the sun or any celestial objects subject to consideration for perspective?
Yeah, I think that this means is it heliocentric or geocentric? If it's this or that, I think that's the question. maybe it's the sun that's spinning around us. Is that what he means?
Yeah, if we give
Adam?
that the sun movement is due to the spin of the Earth, is the observation of the sun or any celestial object subject to consideration for perspective? In other words, do you omit perspective?
Yes. I exactly. I omit perspective because they are too far away.
Okay, right, and yeah. To conclude with the vestibular system, yes, that is your own bodily function, so to speak. So, essentially, we can't feel it, accelerometers can't feel it, but yet you believe this. You believe that we accelerate and decelerate, etc., as we travel around the sun. Yeah.
Well, who said that accelerometers don't detect it?
Glowbusters. That's Bob Nodell.
Okay. Okay. I wish he can just post a link here, and I'd like to say something about Bob Nodell. I saw a part of his show. He was talking about gravity, that it's he knows that it's acceleration of 9.8 meters per second, and I've heard him talking as if he's talking about the palm of his hand. And I'd like to say that anyone who had aviation training knows that everything is affected by a downward acceleration of 9.8, because that's how they calculate the radius of the turn of aircrafts. And I think if he dug down in his old books, he can remember that.
So, from Domesticated Primate, who asked, this should be an easy question for you. When in the northern hemisphere pointing at the sun, is it winter, and vice versa? So when the northern hemisphere is pointing at the sun, why is it winter?
No, that's the opposite. I think he got it the other way around, because when the northern hemisphere is far from the sun or pointing away from the sun, that's our winter here.
Okay, so from SE Montreal, do you believe that we are traveling at 4 million miles per hour at 11 different vectors?
I know only one vector. That's the 30 kilometers per second. I don't know how many in hours that would be, but I don't know anything about the solar system speed. I have no tests to conclude. I mean, if there's something that I can use to test that number, I would gladly do, but I don't have anything to test it.
Okay, so from Sky's the Limit, most globies say that gravity overcomes the spin plus orbit movement we should feel. So okay, so that essentially is the belief of the globers. Also tell Crowxe that spin shouldn't be felt, but spin plus orbit should.
Oh no! If we cannot feel the spin, which is once every day, then how can we feel that once every year? We cannot. No, simply we can't.
Okie dokie, right, okay, so we've run out of questions. I think we've held your toes to the fire for long enough there. Is there anything you want to say before I round up?
No, just I'm thanking everyone who asked questions. They were all good questions. Some of them were so tough for me. I don't have answers for them. So thank you, everyone. And thank you, Ranty, for the floor.
No worries. And seeing as you've done this presentation again against Brian's logic, would you be willing to entertain a 1v1 with Brian, essentially? But it would essentially be me moderating, but it would be unquestioned. It would just be you two getting into this.
Yeah, that's okay. That would be fine.
Okay, right. I'll get something sorted then for that. Okay, right. So let's. I don't want to save that. Right. Well, thanks very much, Crowxe, for stopping by. I do appreciate you. You managed to join. You got your technical issues sorted out, and we were able to do this live. And thank you for staying around and answering all the questions that people put to you. So, thank you for doing that.
Thank you. Thank you, Randy.
No worries. Right, I'll call you back in about 5 minutes, bud. All right.
Okay.
See you in a bit.
See you.
Right. Okay. So, yeah, essentially that's that. that was Glowbertha, Crowxe, and he came in to tell us about Sunspeed and to basically go back over some of the stuff that Brian's Logic had put out there with a presentation of his own. So you heard the questions. I asked him the questions. You heard his answers. I'm sure you'll leave some stuff in the comments section when this is all rounded up and finished. In the meantime, I need to thank everybody for stopping by. I'm still in my dressing gown. I might go live actually again in the next 10 minutes, so stay tuned. I just need to set a new stream up. So, with that in mind, I'll end this right now, and I will see you all very shortly. I'm sure you will all tune in just 10 minutes time, and I'll see you all in the next one.